It's my pleasure to have Dr. M. Rajeevan. He's the Secretary of the Ministry of Earth Sciences. He's a person with considerable technical expertise, including in monsoon forecasting models. Given today's situation, I think there's nobody more appropriate today. So probably we'll talk a lot about Kerala floods, about the monsoon variability patterns and so on. So Dr. Rajeevan, I'll start off by asking you about why is it that in our monsoons, I mean, it has become so, the rainfall patterns seem to have changed so much. I mean, there seems to be less number of rainfall days, but when it rains, it pours, you know, and so this thing called drizzling has virtually gone down. Is there any reason for that?
Yeah, so actually that is true that during the monsoon season, if you analyze the last 50 years of data or so we find that the increase in frequency in terms of heavy rainfall, very intense rainfall events, and the frequency of the low was what you said, the drizzle rain is decreasing, and so that is attributed. That is very well reported, well documented, and it is not only in some parts; it's throughout India. It's happening, and so what happened earlier? We used to have some, for example, 15 centimeter occurs in 24 hours. The same 15 centimeter now it occurs in 12 hours. So that kind of changes have been occurring, and it's well documented that it has been reported. Also, it is linked to global warming. There's no dispute on that. So global warming has an effect on this monsoon precipitation, because if temperature goes up, atmosphere has a capacity to hold more water vapor. So more intense storms can develop in a short time. So if we really analyze the large scale seasonal rainfall, there is not much change. Monsoon has been always stable. So maybe year to year there are a lot of variations. But over the last 50 years, 100 years, monsoon has not changed. But this intensity, increase in intensity rainfall, especially on daily basis, on hourly basis, that is well documented. It is related to global warming.
How do you say it is related to global warming?
Warming, well, there are studies relating to temperatures. So we attribute it is mainly the Indian Ocean has been warming. If you really see the whole global ocean, the Indian Ocean is warming the fastest rate, and then considered to any other oceans. Indian Ocean warms the fastest rate. The warming rate is highest over the Indian Ocean. And Indian Ocean is warming up very fast, so that has a role, because most of the water vapor comes from Indian Ocean. You know, the monsoon current brings a lot of moisture from the Indian Ocean, and so that has a lot of relationship with that.
So, as a forecaster, what challenge it poses you in predicting this erratic behavior, and how close we are in predicting this volatility in this weather pattern?
Yeah, that's a very good, interesting question. See, already the weather prediction is a tough proposition, and we have been improving a lot. So last 10 years we have improved in terms of modeling, improving in weather prediction modeling, as well as we have now one of the best computers available in the world. And so we use the best computers, we use the best models, we have the best technology in terms of observations, everything. So climate change has added another component into this seriousness as the difficulty in weather prediction. And frankly speaking, we don't know how to tackle it. So frankly speaking, we have not really understood how much the effect of climate change in terms of the challenges in the weather prediction. But we know that when we predict, for example, a particular amount of rainfall, the aberrations due to climate change also can add to some uncertainty. So we are not able to attribute that uncertainty due to climate change, and we are trying to work out that kind of changes. And so once we know that how much changes can come, because that also is not a very steady changes. You know, it's a really fluctuating changes in the climate change. So we are trying to find out how much is the error which can come from the changing of the climate, the basic climate change.
And what is the challenge we face in spatial projection, that this area will be, I mean, we have
so at present we
last 10 years, but what is the difficulty that we are facing now to go to a much smaller unit and we can predict
so
that?
At present we give a forecast at the district level. So we have about 660 districts. And so if you really assess the skill, we can, for example, if you assume a particular district, we can give a forecast up to, skillful forecast I am talking about, 3 to 4 days. Quantitative. So, but beyond that, now we have come out with a model in which we can calculate probabilities. whether the rainfall next 3 days, what is happening, whether it will increase or whether it will decrease. That kind of a qualitative change we can tell. So, that also we are able to tell in with a lot of good skill up to 10 to 15 days time scale. So, that has really revolutionized, especially for farmers. You know, the farmers who are in the field, they want to know not tomorrow's weather, they want to know next 10 days what will happen, next 15 days what will happen. For example, now it is raining, they want to know when these rains will stop. When it is not raining, they want to know when the rains will start. So, that kind of the so-called we call active break cycle in the monsoon, we are able to predict almost 10 to 15 days. On an experimental basis, we have started block level forecast. That means still go down below the district level, and about 6,500 blocks are there in the country. So, we are trying to work out, because we have developed a model with its resolution of 12 kilometer. I mean, every 12 kilometer you can predict the weather and variations. So, blocks are almost of 10-15 kilometers scale. So, we can theoretically we can predict weather at a block level. The block level already we started from 1st June we are giving almost 200 blocks now.
What is the accuracy so far in 200 blocks?
Well, we are just started we assume that there will be good skill. So, probably we may at the end of the monsoon season we will assess it and come out.
So do you think river linking is a solution to that, to these devastating floods, or do you think that's too radical a solution that will come with its own set of problems?
As a climate scientist, I personally feel it may not be a good idea, linking rivers. So, but as I said that I am not an expert to really comment on that. And because each river has its own ecological ecosystem. And especially there are comments, there are suggestions saying that don't allow the water to go into the sea. That is ridiculous, because Bay of Bengal, for example, North Bay of Bengal, all these river water comes, Ganges, Brahmaputra river. So, there is a lot of fresh water inflow, and that makes the dynamics of the Bay of Bengal. If the fresh water is cut off, the whole dynamics of the Bay of Bengal will change. Then no monsoon lows, monsoon depression, nothing will form. So, it will really affect the whole monsoon circulation. So, I think we have to be very careful in taking such kind of decisions. More scientific inputs are required before we take the decision. It may be a good idea to so that intention may be good, but then we need a lot of scientific analysis.
Sir, I wanted to ask you, as far as the science of all of this goes, right, we are learning all the time, and of course, the modeling abilities is what's really dramatically changed the way we predict the weather. But can you think of certain spaces in which, it would be helpful if we were able to develop more? Like, what are, according to your experience at least, the gaps where if we knew more, we'd be able to do better?
So, we need a lot of observations. Observations are important. Models has, of course, there are a lot of biases. Models are little approximations. These are mathematical equations. We solve it using computers. But then there we make a lot of approximations, and there is a lot of physics involved with it. It's all calculation based on physics, and many of these physics understanding of physics is limited because it's all occurring somewhere in the space. So, we are not able to go and touch that, we are not able to see that observations. So, we can only do remotely, say for example using satellites or sending radar information. So, we need more and more observations of this kind of physical process which occurs in the atmosphere. We have very limited, but our understanding for if you take last 20-25 years, it has improved a lot, because satellites have really revolutionized this idea. So, we know now better about clouds, and in any model, any weather prediction or even climate model, clouds is the most uncertain issues. And finally, the clouds has to form to get rain. And so, any change, any problems in the prediction of rainfall is basically related to the prediction of the clouds. And especially in monsoon, here monsoon clouds are still convective in type. So, for example, you may be, some people must have gone to, for example, US, there the weather is not very abrupt. The weather is coming up for next 2 to 3 days. We can very well predict. Here it is not so. Morning it will be very blue sky. On afternoon by 2:30, 3 o'clock, big development of thunder clouds. It will rain. Then 5 o'clock, 6 o'clock, everything is gone. Again blue sky. So that kind of it's called convective clouds, and that doesn't occur especially in the middle latitude or exotropics. It's very rare. And that information about how the convective clouds forms and what is the physics of that cloud, it's very limited. Then also in the prediction, weather prediction is nothing but an initial value problem. I mean, if you know the present state of the atmosphere, you can predict more. So you have to define the present state very accurately. If any change, any small errors in the present state will go on accumulating the errors. So that's why our predictions goes after 3 days, 4 days, it goes down. So it's not perfect. The initial conditions are not perfect because we have very vast oceans. We get very less data from the oceans. So we are not able to pinpoint very correctly the initial states. There are a lot of errors.
There's a lot of debate on the science of global warming, and a lot of governments are skeptical about it. Of course, the biggest being the US. So is the Indian government consider global warming perfect science, and does it take it into account while forming policy?
Indian government is not like US government. They appreciate this global warming is taking place. And as you know, the Ministry of Environment and Forest, they are responsible for all policy decisions. They talk to UNFCCC, they talk to IPCC people. And our Ministry of Earth Science is responsible for the basic science. We don't involve in, for example, we don't make policies. But our inputs, basic science inputs, go to them, Ministry of Environment and Forest, and they take into account for making the policies. And we have a center in Pune, IITM Pune. We have a center called Center for Climate Change Research, CCCR, where we run the big climate models. And so we basically do research on why the global warming is taking place. And next question is what will happen next 30 years, 40 years, 50 years. So climate change projections we call. So far, no Indian model has participated in the IPCC projections. If you really see the old 5 reports, you will see all the models from US, UK, Australia, Japan, that kind of. This will be the first time an Indian model will be participating in the next assessment. So by next year, by this year end or middle of next year, we will be submitting all the end. So we accept that global warming is not a old story, it's not no more myth. It's really happening. Global warming is really happening, and there are repercussions related to global warming. We should accept that.
Sir, I'm Shruti. Actually, the Gargill committee had already submitted a report in 2011 about the flood situation in Kerala, but there was not much done about it.
I don't want to comment on the Gargill committee. You
can comment as an expert.
So of course he has given some good suggestions. For example, you take care of the environment. You take, for example, don't cut trees and the forest, and don't fill up the water bodies, and that kind of very, for example, a coastal zone you have to protect it. These are all good suggestions. But then it's very so then there is one suggestion from one side. Another side, you want to make development, you have to make industries, you have to develop buildings. So government has taken the decision not to accept it. So Gargill committee. So
Kerala is never prone to floods. Like this time you had 2 events. I mean, you had that cyclone Oki, and because normally we used to have all these things mostly in Orissa and Andhra. The Bay of Bengal side was more prone to this. What has happened?
We are not sure exactly what is really happening, but there are observations, recent observations, very clearly suggesting that the Indian Ocean, as I told, the Indian Ocean is warming, especially the Bay of Bengal, Arabian Sea side. So more tropical cyclones are likely to form over Arabian Sea. When you compare Arabian Sea and Bay of Bengal, we get more cyclones over Bay of Bengal. Yes. But recent years, Arabian Sea is warming much faster and circulation changes are there. So we tend to get more cyclones in the Arabian Sea.
So is this a new phenomenon?
No.
When do you think this warming has
maybe last 10 years or so. So these changes have occurred. So Arabian Sea is now more prone to tropical cyclones and this kind of weather. So and that can really damage the whole Western Ghats.
So that's a very serious.
Yes. So that's why probably, I don't know whether you are aware. Yesterday we took a decision to set up a cyclone warning center in Kerala.
So coming back to the Gargill report, after the Gargill report, there was the Kasturirangan report, which apparently was the mandate, unofficial mandate was to sort of dilute the Gargill recommendations. Now already states, the Western Ghat states are writing to the Environment Ministry saying even Kasturirangan should be diluted. As an expert, do you think the Kerala floods would be a significant event in changing that discourse?
Well, I don't want to comment about these 2 committee reports. The reports are submitted to other ministry. It's not to Ministry of Environment, Earth Sciences. So it's submitted to Ministry of Environment Forest, which I don't want to comment because as a secretary, I'm not supposed to comment. But for example, the Kerala floods, a lot of landslides have happened. And people are seeing that a lot of, for example, when these buildings are coming out, when the mud and the sand are coming out, and we see that there are no trees. Okay, so wherever landslides are there, wherever the deforestation is happening, the landslides are mainly caused by heavy rains. And when it is, for some Kerala, it is getting rain right from the beginning of the season. From 1st June itself, it was getting more rain. July was more, June was more, July was more. So they have been getting a lot of rain. So all this water will go into the soil, and if additionally any rain, it will become the soil will become very small, brittle. Now, if just to put little pressure, it will come down. So landslides, and if trees are there, if there are enough trees to support, this won't happen. So one immediate impact, especially in where the slopes are very steep, especially the Western Ghats, the slopes are very steep. Similarly, Uttarakhand in northern parts. These are the two regions. Deforestation can pull down landslides. It can bring more landslides. And so that's why one of the recommendations of Gargle committee was not to, for example, make the deforestation. So you have to be a little careful.
There's a lot of back and forth on this, this man-made problem, open the dams, didn't listen to the Gargle report. But I also think, I've also heard a lot about how, as you yourself said, Kerala received a lot of rain. So in this particular situation, where do you personally, as a climate scientist, come down on this division of blame between man-made issues and the rain? What is the bigger factor in causing this crisis?
Of course, the rain was very high. There's no doubt. As I said, that June was very high, July was very high. Soil was already saturated. It was so any soil, once you become soil wet and it is saturated, then whatever rain comes, it will simply flow. It cannot go inside the soil. Percolation will not happen. So everything will flow. So the first 2 weeks of August rainfall, it was a little extraordinary rain. It was not a typical rain. It was more rain. And that has really caused the dam to, those people have to open the dam because more water came into the reservoirs. But there is a story, there is a saying now, people say that by July itself, by end of July or even middle of July itself, all these dams were full. And so normally people what they do is, if in outside I am talking about, for example, you must be aware about the Colorado State River. It's a very famous river, Colorado River. It runs to 7 states and runs from a dry place to arid and very rainy place. But they do a very good management, the Colorado River. It's a very famous basin. And so they look into the weather forecast for next 5 days, 10 days, 15 days. Even in seasonal time scale, they see how much water you can expect it. So they have a kind of a decision support system, and based on scientific methods. So for example, if they know that this is the water level, and they will calculate how much water can come for next 2 days over this reservoir, next 3 days. And if this water level is going to be out of above the danger level, they will start removing it. They start releasing it before anything seriously happens. I think that kind of thing, it was not done in Kerala.
Do you think is it the number of observation or the number of variables that we are doing that can we predict? Like Britain, it is an island, and then you can predict in the next 2 hours whether it's going to drizzle or it's going to rain. How far we are from predicting at that, even though it's not only spatial but also the time process, can we predict with that precision?
Yeah, we are trying now. So we call nowcast. For example, what will happen next 2 hours or the next 6 hours. So that we cannot run a model and do it. We don't have a kind of modeling system for that. For that we use radars. We have about 23 radars in the country, and radar can really track the weather systems moving. For example, if if I can give you that phone numbers, you can also be the subscribers to that phone. And then they send you the messages. So they send the messages by tracking the radar images. They can tell you the next 2 hours where it is going to rain and what kind of rain it is, whether it will be a thunderstorm or it will simply drizzle. So that is, even now we started doing it. Many cities we are now doing it. So we are immediately putting 10 radars over northwest Himalayas, 3 the Himalayan states, hilly regions, So we can put a small radars, we can see up to 50-60 kilometers. So we are putting 10 radars, and we have another it's called C-band radar, which can see up to 250 kilometers or so. That we will be having about 11 radars, which we are going to place the order by next year. It will start coming. One will be in Bombay, one will be in Mangalore, one will be in Ahmedabad, one will be in Port Blair. So that's kind of, so wherever the big gaps are there, we are going to fill it up. So we will have by 2020, we'll have about 50 radars. It's a beautiful network.
Will it also help in making more localized predictions?
Yes, radars are useful for localized predictions.
So over the last several years, I mean 5 years at least, we've had these extreme rainfall events quite frequently. I mean, you have Kerala and then Bangalore and Chennai and Kashmir. And every time we seem to be talking about either exceptional rainfall over a very short time, or rampant unplanned urbanization, etc., etc. But this has become a pattern now over the last 5 or 6 years. So, as the government, is it planning some kind of a holistic study, analysis, policy? Because this, it seems that irrespective of how much importance we in the media or the people as a whole have been giving to climate change, I think there is now clearly, as you said, I mean, as I came in, I heard you saying that there is certainly a change that is happening, and it's real, and we have to tackle it. So, and we are seeing this over the last, it's not just Assam or Bihar or UP where the flooding is happening. So, as the government, policy-wise, where are we looking?
Government, as I said, government is aware that climate change is happening and this kind of events are increasing. And see, I don't know, there is a famous statement by Professor White. He is a famous hydrologist from US, Colorado State University. He told the floods are made by gods, but flood disasters are made by humans. Okay. And so unless we have a kind of a very full-fledged scientific flood management system using scientific methods, not just now for example dams, for example, in India, in my understanding, I may be wrong also, no big reservoirs don't have a decision support system. Okay, based on scientific methods.
That is, we don't know
when to open, how to open, when it will be the right time to open, who is responsible for opening. Of course, the engineers will open. But the question is, when the decision is to be taken, nobody knows. I am not complaining anyone, and I am not attributing the Kerala floods to some individuals. Okay, but there is a common perception that in India, most of the reservoirs, the flood management systems are not managed by systems are supported by science. So no scientific method, no decision support system is available, except maybe one or two. Bakranangal, I remember it was there, but in plains like Narmada or Godavari, no snow. It's a straightforward problem, but I am very sure. I think we don't have that kind of system. We need that system. Otherwise, it will simply leave it to some engineer who thinks that water has become more. I will release it today, so I will release it today.
Sir, also agriculture, because across the world, sooner or later, climate change is affecting production.
That agriculture community, they are aware about it. So for example, if we read the literature, so they write a lot of papers saying that because of this water, for example, wheat production will change, rice production will change. They are aware about it. And but on day to day, how it will affect the farmer, particular farmer and a particular field, now that kind of quantification is not done. So it's a kind of only on academic way they are doing it. But I think we need to have little more better strategy how to tackle the climate change in terms of agriculture production. We have to tell the farmers properly, saying that because of this there could be changes in the weather patterns, climate pattern, temperature pattern that may affect your crop yield finally.
The one thing that insurers in agriculture or different sectors that they feel is about the weather. So there is a scope for monetizing that prediction that you do. If we do, let's say 50 radars or make it 100 radars. So, and this data is real time shared with them, so that it will take out the scope of saying that the assessor misreporting or underreporting and over-reporting of the rainfall or whatever damages. So like you said that in a dams water, information-based decision making. So it will add to the information. That's the one, if you can do that. And the second is like, I see an example, the Uber and the Olas are just monetizing GPS. India, we have Bhuvan, we have not allowed its platform to be worked on, monetized upon. You do so much weather prediction. Are you thinking of monetizing this? Because there may be many service providers who would like to tap it.
Yeah.
Why not? Even Uber itself would like to build in it in software that if you are, so this is what. So are you open to monetizing this prediction that you are doing?
Our forecasts are free of cost. Anybody can take it and make use of, further polish it, further value added can be done, and they can give it to some particular industry, particular user sector. They can provide. We will be happy to provide them. But at present, nobody is coming forward, and except this agriculture communities and maybe the insurance community, they are coming. And especially over the marine area, for some over the oceans, the ship industries, they come. So they also need this kind of inputs. But we are open. I think, but this is a very good suggestion. I think we should do that.
We'll be open to do that. Sir, again, question. See, I think the IND that is under you has been getting its forecasts quite right. I think you predicted drought in 2014 and 15. You predicted normal rains in 2016 and 2017. And this year you are predicting normal, whereas SkyMet is predicting that second half is bad, whereas second half has been good so far. What do you think has changed? How has your accuracy improved? We are again talking of aggregate. We are not talking of what has happened.
Monsoon is a very gigantic system and very complex system, but it is a beautiful system. It's a beautiful science, and so as I said, that again observations are big constraints to us. We don't know much about some of these factors of which cause monsoon variability. We know El Nino is affecting, we know Indian Ocean is affecting, but last 30-40 years, frankly speaking, monsoon research is not only in this country. It's all, for example, US, most of the US scientists, atmospheric scientists, they are more worried about Indian monsoon because it's a beautiful, challenging area where they can do their science, but a good science can come out. So all of us are working, but last 30-40 years, with all this combined research, if we put together, we have a better understanding. We know much better than about Indian monsoon. Compared to last 30 years, but still I am very humble. I will say that we know very little about monsoon.
Do you think that the funding for meteorology in India right now, whatever it's a federal subject, is it adequate?
Yes. Actually, if you as I said, the 2006 our ministry was formed, MOES. So last 10 years, for some last 10-12 years, the funding has improved a lot. Well, funding has improved. So whatever we want now, government is giving. So we should be thankful to the government, and because of that, things have changed a lot. So whatever progress we have achieved last 10 years, mainly because we got more money. So for example, 400 crore we could spend it for monsoon mission and get a lot of. So the monsoon mission model which we use now, prediction for monsoon prediction, was improved much because of the inputs we received from all these academic people from the world.
I don't know, I mean, one of our colleagues who covers, I think she's not here, Soumya. So she was telling me something about, I think she heard from you, about how they would go out in boats into the sea to figure out monsoons, etc. Can you tell us something more about that?
Yeah, that we see, as even 1950s and in early 1960s, we are aware that ocean play an important role. And so then the ocean observations are very scarce and we don't get any. So we used to have ship observations. We take our ships and go. And we had two big campaigns called Indian Ocean Expedition, IOE. It's a very famous expedition we had. So we used to take our people, and that was then 1979. There was an experiment called monsoon experiment, in which all these countries in the world who are doing monsoon research came up to India and did a research in 1979, and it was a huge project, and they brought their aircraft, they brought their ships, and it was a beautiful campaign they did. And so these observations, as I said, these observational campaigns are very, very, very important. Each observational campaign will give you additional information about how the monsoon process is happening. Now, under monsoon mission, we launched another recently a program with the UK.
IIT Pune has recently started monitoring PM1. How big are the challenges, considering that there are no standards for PM1, you know, what it should be, what is above mark of danger, and especially since there are no standards abroad either.
PM1 recently we started in Mumbai also we started, and recently we put an observatory over Chandni Chowk. there we put PM1, and Dr. Bey, who is doing this job, he, of course, I am not an expert in air pollution. He was saying that PM1 is more dangerous than any other PM 2.5 or PM, because PM1 directly can go into your lungs. It's a very small particle. And as you said that there may not be any kind of standard levels or norms to calculate whether it is above normal, below normal. So, but this is the right time that we start taking observations. Probably maybe a couple of years later we may be able to come out with a kind of a strategy or come out of threshold levels.
So these dust storms that happen, you mentioned Dr. Bey. I mean, his paper which came, the last one, was about this storm that appeared in the Middle East, and then it sort of moved in this direction. And so, has the understanding of this dust storm phenomena improved since then, or are we? I mean,
and we have better understanding now. So the dust storm we know, using satellites we can measure where the dust storms are happening. Dust storms normally happen where a lot of desert is there, a lot of dusts are there. So it doesn't happen in cities. So we get information only through satellites. And once it forms, then models can predict how it can go, because it goes with the winds. So we know how the wind circulation will flow, so that we can really calculate how much dust can come to particular region. So now I want to make another, of course, some of you may be aware that our ministry has been given responsibility by Ministry of Environment for us to develop a air pollution emergency warning system, which we are working, and it will be operational by October. For Delhi. Once we do it for Delhi, so you can expect by before next November Diwali season, we will have a prediction system for Delhi.
Dr. Rajeevan, thanks. We had 1 hour of very stimulating discussions.
Thank you very much.
Thanks a lot.
Thank you.
Pleasure. Yeah.